It's a real puzzle, isn't it? We've seen so much progress in how we think about teaching, all the cool tech now and, tons of research.
Yeah,
Yet
absolutely.
actually getting knowledge to like stick in the students' brains effectively, it still feels like this huge hurdle.
Hmm.
You hear about teacher burnout, kids struggling. It makes you wonder if we're missing something fundamental.
Right.
And that's where this interesting idea comes in, Brainpage theory from Shiva Narayan taxshila page.
And what's striking there is the focus, isn't it? We often get tangled up in, say, curriculum debates or the newest teaching fads.
Yeah.
But this theory points straight to the core of it all,
Yeah.
the brain. Brain page theory tries to give us a map, sort of, for how information should ideally travel from a book or whatever into the brain.
Exactly. So for this deep dive, we're going to unpack the main ideas of brain page theory. We're using Shiva Narayan taxshila page's work as our guide here.
Getting into the engine room, like you said.
Yeah, exactly. We'll look at this concept of a student's brain having its own learnography, these built-in taxshila teachers, and these different layers or dimensions of how knowledge moves, specifically that book-to-brain path.
And if you step back, the theory is basically saying that real learning isn't just, throwing information out there.
Right.
It's about actively cultivating the brain's capacity to grab, process, and importantly, hold on to that information.
Mm.
Terms like learnography and brain page development really point to that internal active work that has to happen.
Okay, so let's start there. This learnography idea, the text explains it as basically training a student's brain to think differently, and crucially, to get better at understanding knowledge transfer itself.
Hmm.
And central to this is brain page development, which is about creating these pre-trained small teachers or taxshila teachers inside the student's head.
Yeah, like training the brain to be its own efficient learning guide.
That idea of the student developing their own internal teacher, that's pretty powerful. It suggests real learning means you can not just recall stuff, but work with it, almost like having your own little expert inside.
Exactly. You internalize the process, not just the facts.
And the basic idea behind it all is pretty simple, isn't it? Everything we learn happens in the brain. Everything we do with that knowledge is done by the brain.
Seems obvious when you say it like that.
Yeah, but the theory argues our school systems maybe haven't always designed around that core fact. Then there's Brainpage Association, described as the software that makes it all work for practical things like reading, writing, understanding.
That emphasis is key, the brain as the place and the tool. And thinking of Brainpage Association as software, it implies specific neurological wires, processes taking new stuff and weaving it into what's already there.
Right. Now, this is where it gets really specific. The theory lays out 7 dimensions. 7 ways this book-to-brain transfer is supposed to happen during school time, creating these smart brain page modules. Let's tackle the first one, the definition spectrum.
Okay. Yeah, and it's interesting how granular it gets. The definition spectrum, it focuses on the naming address and the definition address for things in the brain.
Addresses, like location.
Sort of mental addresses, yeah. Within the association cortices, the brain's higher-level thinking areas. And it introduces this core unit called a Zeit. Think of it like a knowledge packet. Name, function, definition, all bundled together.
So a Zeit is like the atom of knowledge, the basic building block.
That's a good way to put it. It bundles the label, the what it does, and the what it means. Effective learning starts with the brain properly encoding these Zeits.
Makes sense. Okay, dimension 2.
That's the function matrix. This one's linked to insular learnography. And the insular cortex, it's a brain area involved in, like our internal awareness, body states, feelings.
And the function matrix flips things around, doesn't it? The text says content follows the questions, not the other way around.
Exactly. Instead of learn, then practice, it's practice to learn. The idea is tackling questions first gets you exploring this space learnography.
Space learnography.
Yeah, it sort of ignites the learning drive and pushes you to build better quality knowledge because you're actively hunting for what you need.
So the brain's actively seeking problem solving from the get-go.
Precisely. It's a very different dynamic. It engages the brain immediately, trying to find solutions, focusing attention.
Okay, dimension 3, the block solver. This is called differential learnography, guided by the prefrontal cortex.
The brain CEO, basically. Planning decisions.
Right, and this is about breaking knowledge down into smaller chunks, blocks.
Mm-hmm. Making it easier for the brain to chew on. This really fits with what we know about working memory,
Yeah, avoiding overload.
Exactly. Break complex stuff down, reduce the mental load, let the prefrontal cortex handle each block more effectively. It's crucial for problem solving, finding those exact solutions.
Dimension 4 moves us to the hippocampus. That's in the parahippocampal gyrus, right next to the hippocampus itself.
Key memory zone
Oh.
and navigation orientation.
And the theory calls it the brain's search engine for facts, events, building these modular brain pages through pathway learnography. That space navigation idea is interesting for memory.
It's a great metaphor, isn't it? The hippocampus helping you find your way around your own knowledge, helps retrieve things. And modular brain pages suggest these linked networks of info built up by that internal search.
Okay, next is number 5, the module builder. Linked to visuomotor learnography, cerebellum, basal ganglia circuits.
The motor system connection.
Yeah, it says this is about actually building the brain page modules through motor pathways, and it makes this point that all learning ultimately converts to motor knowledge somehow.
That sounds a bit weird at first, maybe. But think about it. Even abstract ideas affect how we act, right?
True.
The basal ganglia movement, habits, rewards, they're vital for cementing learning into usable skills and structures. This dimension really links thinking, feeling, and doing.
Creating the whole knowledge structure. Got it. Dimension 6, task formator. They link this to Einstein's genius brain and visual learnography streams in the visual cortex.
Dorsal and ventral streams, yeah. Processing what we see.
So this is where higher stuff happens. Analysis, computation, pattern recognition, creating mental templates, even using face recognition somehow.
Well, the visual cortex is incredibly powerful. It's not just seeing, it's abstract processing, building those mental models or knowledge templates. Linking it to tool design suggests that deep understanding involves visualizing, manipulating ideas mentally.
Makes sense. Okay, last one, dimension 7, dark knowledge. Also linked to Einstein's genius brain, visuospatial stuff.
For QBS.
Posterior cingulate.
Areas involved in self-awareness, memory retrieval, mental imagery.
And this is pegged as the source of creativity. New ideas, innovation, stuff beyond just conscious thought.
Right. It's tapping into intuition, learning passion, that inner drive, leading to smart brain pages for learning, working, earning, the whole package.
It even mentions something about a live and dynamic blackboard effect in classrooms feeding into this.
Yeah, LADE. It suggests the classroom dynamic itself can spark this deeper, almost unconscious processing. This dark knowledge idea is quite provocative, suggesting there's this whole layer of intuition and unconscious work driving breakthroughs.
So those are the 7 dimensions, and the theory groups them, right, into 5 categories.
Cognition, that's dimensions 1 to 3. Then limbic emotions, passion, drive covering 4 to 6, roughly. And motor action, feedback, speed hitting 5 to 7.
With intuition as an advanced motor thing driving creativity?
Exactly. It shows how thinking, feeling, and doing are all interwoven in this model of learning. The limbic part highlights emotion and motivation, which, often gets sidelined. And framing intuition under motor science is interesting. Suggests a deep, embodied knowing.
So how does this all actually, work in practice? They talk about cyclizide thalamic rehearsals.
Right, the practical application bit.
It sounds like you take the info from the book, the source page, and you mentally rehearse it on this prefrontal thalamic cyclizide, like a mental loop.
Connecting the front brain to deeper relay centers, yeah.
You do that 3 to 5 times. Then book closed, you write down the modules, what you remember, on a motor side page.
So it's a source to brain to action loop.
Yeah.
Source page, brain page, side page.
Exactly. That process seems very active.
It really emphasizes engaging directly. The mental rehearsal probably helps short-term encoding.
Right.
And then writing from memory forces, recall, deeper processing, because you have to actively rebuild it.
And this isn't just for class time, right? It applies to homework, study.
Yeah. Home learning, exam prep. The theory even says teachers do this too. Create their own brain pages to guide their teaching and questions.
So the teacher is also modeling this internal processing.
It underscores their role as a facilitator who's actively thinking about how students' brains will likely receive and process the material.
Which brings us back to that starting problem, why this theory even exists. The stressed, burnt-out teachers, the feeling that knowledge transfer is often failing.
Yeah, despite all the tech and pedagogical advances.
The core argument seems to be that knowledge often just isn't landing properly, not really taking root in students' brains with current methods.
It directly confronts that efficiency issue in education. If the basic transfer isn't working well, even great methods might fall short. Brain page theory offers one explanation and a potential fix, grounded in neurology.
And that's the bottom line, isn't it? That school knowledge transfer has to be based on neuroscience, on how the brain actually learns. This insular brain, or side brain, is the central hub.
Yeah, coordinating these brain pages through all those active dimensions.
Because everything is learned in the brain, so understanding brain learnography is just essential for managing learning effectively.
That brain-centric focus is vital. Grounding practices in brain function aims for more efficiency, less wasted effort, benefiting everyone. The insular cortex as coordinator highlights things like attention, awareness, integration. They're key.
And the source material mentions specific research areas underpinning this, like how student brains work for learning, writing, understanding.
Mathematical dimensions of transfer, applying dimensions in space learnography, the role of school hours, and, yeah, the teacher stress issue.
So it seems like a pretty comprehensive approach they're building.
It definitely seems to be trying to connect neuroscience, math, and practical classroom realities to tackle the knowledge transfer challenge.
Okay, so wrapping this up, this deep dive into a brain page theory, it really offers a different lens on how knowledge gets from, say, a book into our heads. We've got learnography, brain page development, the Zide unit, those 7 dimensions.
All proposed as crucial for effective learning transfer in schools.
And the big message feels like, if we align teaching with how the brain actually works, maybe we can finally address some of these persistent problems in education.
What stands out is the level of detail, trying to map the neurological steps. It goes beyond general principles into specific brain functions involved in grabbing and holding information.
And for you listening, if you're always trying to figure out how to learn better, more deeply, maybe thinking about these dimensions could offer some clues, even outside school, just considering how you take an info, process it, recall it through these different modes might unlock something for your own learning.
It definitely pushes for a more conscious way of learning, thinking about the how, not just the what.
So here's a final thought to chew on. If our traditional ideas about knowledge transfer have maybe missed this brain-centered view, what other assumptions about learning might be holding us back? And how could a theory like Brainpage, focusing on these intricate brain processes, maybe spark totally new ways for us to learn and use knowledge, not just in school, but, everywhere in life?